In question 27, we have a graph of current against potential difference for an LED, and we're asked to describe and justify the variation of resistance as the potential difference across the LED is increased first from -1 to 2.6 volts. Well, at this point the resistance is infinity. Resistance is voltage over current, and current is equal to 0 throughout this range. For the second point, resistance reduces to a value of 3 volts over 7 milliamps, which gives a value of 430 ohms. And finally, in the third situation, resistance reduces again, and now to a value of 3.4 volts over 30 milliamps. And this gives 110 ohms. In B, we have a circuit where the LED fails to light. We're to explain why the circuit doesn't work and to modify the design so the LED will light. Well, firstly, the cell is the wrong way around, and also we need a potential difference of over 2.6 volts. Here we only have a potential difference of 1.5 volts. What we could do is we could use two cells in series, which would give sufficient potential difference, and place them the other way around. In C, we have the wavelength of the light as 480 nanometers and the power as 1.2 millivolts. We're asked to find the number of photons emitted per second. Well, the number of photons times the energy of the radiation, which will be hc over lambda for the energy of a photon, is equal to the power. So we can say that the number of photons is power times wavelength over hc, which is 1.2 times 10 to the minus 3 for the power times 480 times 10 to the minus 9 meters for the wavelength over the Planck constant, and the speed of light in a vacuum. And that gives 2.9 times 10 to the 15 photons per second.